Hello students, we are going to discuss paper 14 today. The topic was magnetic field and magnetic effect of current. In question number 1, it is given that a north pole of strength M is equals to pi ampere meter is moved around a circle of radius r is equals to 10 centimeter, which lies along a straight conductor carrying current of 10 ampere. So I is given as 10 ampere. We want to find the work done. The work done is given by the formula mu naught m n I, where n is the number of turns, that will be 1. So work done will be mu naught will be 4 pi into 10 power minus 7. M is given pi, n is 1, I is 10 ampere. So simplifying it, we'll get answer approximately 40 microjoule. So option 2 is correct option. In question number 2, a current of I is equals to 1 upon 4 pi ampere is flowing in a long straight conductor. We want to find the line integral of magnetic induction around a closed path enclosing the current. That means we want to find the integration B dot dl. The B dot dl is given by mu naught I enclosed. Mu naught is 4 pi into 10 power minus 7, and I enclosed is 1 upon 4 pi. So the integral will be 10 power minus 7 Weber per meter. So option 2 is correct option. In question number 3, it is given that a wire in a form of square of side A. This is conducting wire in form of square of side A carries current I. We want to find the magnetic field induction at the center of square wire. Let's say that center point is O. So we want to find magnetic field at point O. Here, for this square, we can consider it as the combination of 4 finite length wire. For finite length wire, if current I is flowing through it, if we want to find magnetic field at particular distance x, given this angle is theta 1 and this angle is theta 2. So magnetic field at this point P is given by mu naught I upon 4 pi x into sine theta 1 plus sine theta 2. So using this concept for this square, here the magnetic field due to each of the conductor at the center is in the outward direction. To find the direction, we will use right hand thumb rule. Current is in this direction, so magnetic field will be coming out from point O. Even from this wire, it will be coming out. Same way for this conductor and same way for this conductor. So all of the magnetic field will be added as the length of wire and distance of point is same. The magnetic field due to each wire at point O will be same. Let's say the magnetic field due to wire AB at O is B1. So B net will be 4 times B1. Now writing B1, mu naught I upon 4 pi. This perpendicular distance will be half of this side, that is A by 2, into This angle is 45, this is 90, so this angle will be 45 and this angle also 45. So into sine 45 degree plus sine 45 degree. So that will be 2 mu naught I upon pi a into 2 times sine 45 is 1 by root 2. So B naught will be 2 root 2 mu naught I divided by pi a. So option 3 is correct option. In question number 4, a long wire carries a steady current. Now it is bent into a circle of 1 turn. Let's say length of the wire was L. Now it is bent into form a circle of 1 turn, let's say of radius capital R. Same current I is flowing through it, and the magnetic field at its center is B. Now it is then bent into a circular loop of n turns. Here the length will be constant. Let's say it is bent into circular loop of n turns of radius R. And the magnetic field due to this n turns at the center we want to find. Let's say the magnetic field is B dash. Here length is constant, so we can write L is equals to 2 pi r is equals to n times 2 pi r, where small r is the radius of n loops. From this we can write small r is equals to r by n. Now magnetic field at the center of one turn is given by mu naught I divided by 2r, and for n turns B dash is equals to mu naught I into n because of n turns divided by 2r, small r is the radius. Taking the ratio of B dash and B, we will get B dash by B is equals to n by small r divided by capital R is equals to n divided by r into r, but small r can be written as capital R by n. So here it will be 1 by r, so this r will be in multiplication. This r and r will get cancelled out, so we'll get answer n square. B dash by B is equals to n square, so B dash is equals to n square B. So option 2 is correct option. In question number 5, a circular coil of radius r carries current I. The magnetic field at its center is B. We want to find the distance from the center at which the magnetic field will be B by 8. Let's say that point is P. So magnetic field at center is B, that is given by mu naught I upon 2r, and magnetic field at P is B by 8. Magnetic field on the axis of a circular ring is given by mu naught I r square divided by 2 into r square plus x square whole power 3 by 2. Taking the ratio of 1 and 2, we will get B divided by B by 8 is equals to 1 by r, this mu naught I, 2 and 2 will get cancelled out, so we'll get 1 by r divided by r square divided by r square plus x square power 3 by 2. So 8 is equals to r square plus x square power 3 by 2 divided by r cube. So 8r cube is equals to r square plus x square power 3 by 2. Taking cube root both the side, we'll get 2r is equals to r square plus x square power 1 by 2. Squaring both the side, 4r square is equals to r square plus x square. So x square is equals to 3r square and x is equals to root 3r. So option 2 is correct option. In question number 6, two concentric coils A and B have radii 25 cm and 15 cm and carry 10 ampere current and 15 ampere current respectively. The coil A has 24 turns and B has 18 turns. The direction of currents are opposite. We want to find the net magnetic field induction at the center. Given R1 is equals to 25 centimeter, R2 is equals to 15 centimeter, N1 is equals to 24, N2 is equals to 18, I1 is equals to 10 ampere and I2 is equals to 15 ampere. Here, as the current in both the coils are in opposite direction, magnetic field due to them at the center will also be in opposite direction. So B net will be magnitude of B2 minus B1. The magnetic field due to coil 2 will be mu naught N2I upon 2 pi R2 minus mu naught N1I upon N1I1 upon 2 pi R1. So mu naught upon 2 pi, N2 is 18, I2 is 15 divided by R2 is 15 centimeters, so 15 into 100 minus N1 is 24, I1 is 10 upon R1 is 25 centimeters, so 25 into 100. Simplifying this, we will get net magnetic field induction at center is equals to 420 mu naught Tesla. So option 3 is correct option. In question number 7, a particle having charge Q is equals to 100 times that of electron, that means Q is equals to 100 E, is revolving in a circular path of radius r is equals to 0.8 meter with 1 revolution per second. So its speed is 1 revolution per second. We want to find the magnetic field produced at the center. Here it will behave as a current carrying loop. At the center, the magnetic field is given by mu naught I upon 2r, and I can be written as Q by T. So 2r T. So mu naught into Q is 100 E, charge on electron is 1.6 into 10 power minus 19 divided by 2 into R is 0.8 meter and time 1 revolution per second, so time will be 1. So B is 10 power minus 17 mu. This will get cancelled out. So option 2 is correct option. In question number 8, for Biosolids law, we want to find relation between B and V. Biosolids law is given by B is equals to mu naught upon 4 pi Q into V cross R, as B is directly proportional to V cross R. B is perpendicular to both V and R. So appropriate option is option 1. In question number 9, in a properly adjusted tangent galvanometer, the deflection for 1 ampere current is found to be 30 degree. Now the coil is turned through 90 degree about the vertical axis. We want to find the deflection in same current. Here initially when current I is equals to 1 ampere was flowing, the deflection was 30 degree. That means the needle was already showing in the direction of magnetic field of Earth. So when you turn it by 90 degree, there will be no deflection. So answer is 0 degree. Option 4 is correct option. In question number 10, for a tangent galvanometer, the magnetic induction produced by coil is equal to the horizontal component of Earth. For tangent galvanometer, we can write B is equals to BH tan theta. It is given that B and BH are equal. So tan theta is equals to 1. So theta is equals to 45 degree. Option 3 is correct option. In question number 11, a proton is fired with speed of 2 into 10 power 6 meter per second at an angle of 60 degree to the x-axis. The uniform magnetic field of 0.1 Tesla is acting along y-axis. We want to find the force acting on the proton. Force on charged particle in magnetic field is given by QVB sine theta. Here velocity of particle is making an angle 30 degree with magnetic field. Let's say this is x-axis, this angle is 60 degree, so this angle will be 30 degree. So here theta will be 30 degree. Write the values. Q is the charge on proton, that is 1.6 into 10 power minus 19. Velocity is 2 into 10 power 6. B is 0.1, that is 1 by 10 into sine 30, that is 1 by 2. So 2 will get cancelled out. Simplify this, we'll get answer. F is equals to 1.6 into 10 power minus 14 Newton. So option 2 is correct option. In question number 12, we want to find the time period for a particle of mass m and charge E moving perpendicular in a uniform magnetic induction B with speed v. The formula of time period is given by 2 pi m upon qb. Remember, it is independent of speed. Here charge given is E, so the time period will be 2 pi m upon EB. So option 3 is correct option. In question number 13, a closed circuit in the form of rectangular hexagon of side A. If the circuit carries current I, we want to find the magnetic field induction at the center of hexagon. Here this hexagon circuit can be considered as the combination of 6 straight wires. As the current is in same direction, the magnetic field at O due to each of the 6 wire will be in same direction. So we will simply add the magnetic field due to all of them. Now as the length of each wire is same, current through them is same, and distance of center from the wire is also same, the magnetic field due to each of the wire at the center will be same. Let's say the magnetic field due to AB at center O is B1. So B net will be 6 times B1. Now first we'll find B1. The distance of center from the side of hexagon is given by root 3 by 2a. You can find it using trigonometry. This angle will be 60 degree, this is 90, this will be 30, this side will be half of the side, a by 2. So r will be root 3a by 2. This angle will be 30, this angle will also be 30. So magnetic field will be mu naught I upon 4 pi r, and r is root 3 by 2a into sine theta 1 plus sine theta 2. Here theta 1 and theta 2 both are same, so we can write 2 times sine of 30 degree. So B1 will be mu naught I divided by 2 pi root 3a into 2 sine theta is 1 by 2. This 2 and 2 will get cancelled out. So B net will be 6 times mu naught I divided by 2 pi root 3a. So B net will be root 3 mu naught I divided by pi e. So option 4 is correct option. In question number 14, a charged particle of charge Q and mass m is fired perpendicular to magnetic field B. So the particle will revolve in a circular path. We want to find its angular velocity. Angular velocity omega can be written as 2 pi by t, and time period is 2 pi m upon qb. So write this value, 2 pi divided by time period is 2 pi m upon qb. This 2 pi will get cancelled out. So omega will be qb by m. So option 3 is correct option. In question number 15, it is given that an electron of mass me and proton of mass mp initially at rest move a certain distance in a uniform electric field. Let's say they both move distance x, and time taken by electron is t1 and time taken by proton is t2. We have to neglect the gravity effect. We want to find the acceleration. The acceleration in electric field can be found by writing the force equation. Force is equals to EQ, electric field, into charge. Charge on both of them is E, so F is equals to E into E. So force on both of them will be equal, and F can be written as ME. As this is constant, we can say acceleration is inversely proportional to mass. So we know that mass of proton is more, so its acceleration will be less. So acceleration of proton is very less than acceleration of electron, or acceleration of electron is very greater than acceleration of proton. So according to that, first statement is correct. Now they are moving certain distance x with uniform acceleration a. We can use second equation of motion. X is equals to, they both starts from rest, so u will be 0 half a t square. As distance traveled by both of them is same, we can say at square is equals to constant. So acceleration is inversely proportional to t square, and we know from here acceleration is inversely proportional to mass, so we can simply say mass is directly proportional to t square. So t1 by t2 is equals to mass of electron upon mass of proton whole power 1 by 2. So option 3 or statement 3 is also correct. Statement 1 is correct and statement 3 is correct. So option 3 will be correct option.